So here is lesson 3-2, solving systems of equations algebraically. We are going to learn about substitution and elimination. That's our objective, to be able to use those to solve systems of equations. So the first method we're going to talk about is substitution. In substitution, you're going to solve one equation for a variable, and you're going to then plug that information into the other equation. So you get that first equation to say y equals or x equals, either one. And you take that and you plug it into the other equation. And then you're able to solve for your first variable. And we're going to do some examples so you'll be able to see. Now, the other type of method is called elimination. The first thing you're going to do there is you are going to match up the variable of your choice in each equation, making them opposite. If I could spell. Once you match up the variables of your choice in each equation and make them opposites, which we'll go over how to do that, then you're going to add the two equations, and then you're going to solve for your first variable. Okay? There are certain situations where substitution is important or helpful, and there's certain situations where elimination is. You know, it really just depends upon the setup of the equations, and you know, there's just some little hints I'll give you as to which one might work better. So in this first example, we're going to use elimination. Now, what we're going to do is take a look at our variables. If we look at our x's, we are going to use the least common multiple of 7 and 3, and we would use the number 21 to help us. If we decide to use the y's, we would use the least common multiple of 4 and 5, which is 20, to help us. Now, it doesn't matter which one you decide to go with, but I like the fact that this is negative and this is positive. That is going to make our, elimination first step pretty easy. Now, remember, step one is we're going to try to get the variables, one of the variables, to be matching opposites. So let's multiply this equation by 5. So that would make this term right here a negative 20. And let's multiply this equation by 4, making this term right here a positive 20. So that's what I mean by matching opposites. So let's multiply each of the top equations by 5. So that's 35x minus 20y equals negative 5. And then multiply everything in the bottom equation by 4. So that's 12x plus 20y equals, what is that, 52, okay? Now the second step says to now add the two equations together. So if we add the two equations together, we get 47x equals 47. And then the third step says to solve for your first variable. So we're going to divide each side by 47, and we find that x is 1. Now you're not done. Both of these things don't mention that this is just how to get the first variable. Once you find your first variable, you have to plug that first variable back into either equation to find your second variable. So I'm going to plug in to this equation right here an x value of 1. So 3 times 1 is 3, plus 5y equals 13. Subtract 3 from both sides. 5y would equal 10. Then divide by 5. So we get y is equal to 2. Now, this is the point that they have in common from what we did in lesson 3.1. This would be a consistent independent set, and you should write that answer as an ordered pair so that I know it's a point that you found. So there is example 1. Now example 2 says to solve by substitution. Now why is that a good choice? Well, do you see here how it says that b equals 2a minus 8? So that means in the other equation we can take out the b and replace it with 2a minus 8. Hence the word substitution. We can substitute it in. So rewrite your top equation, and where the b is, so the b was right here, put a parenthesis, and inside that parenthesis, write your 2a minus 8. You might notice now that we've got an equation that just contains a's. So go ahead and solve it. And we get negative 8 equals negative 9. Our a's disappeared. Now what does that mean? Well, when the a's disappear and you get a statement that is not true, that means there is no solution. If we were to graph this, this is a set of parallel lines. Also, we would say that this set is inconsistent. Okay? That's what would happen for an inconsistent set. Let's look at example 3. In example 3, it says to solve by elimination. We can either choose to make the x's 6's or the y's 5's. Since 1y is already a 5, let's just multiply this equation by 5. We're going to get 10x minus 5y equals 30. And then the bottom equation, we don't have to change at all. You will see that these are opposites. So that's what you're trying to get. You're trying to get one of your variables excuse me, to be opposites, okay? So now we can add the two equations together, and we get 13x equals 52. We're going to divide both sides by 13. And 52 divided by 13 is 4. Now you're not done until you find out what y is. So let's just use this equation here. So 3 times 4, because now that's 4, is 12. 12 plus 5y equals 22. Now let's solve for y. We get 5y equals 10, y equals 2. Write it as an ordered pair. Now that is our solution. Because we have exactly one solution, this is a consistent, independent system. So there is example 3. Excuse me, I'm so sorry. Let's look at example 4. Now example 4 says to use substitution. So if we compare our a's, well, we don't really need to compare them. Let's find, for substitution, let's find the variable that's the easiest. So if the simplest, if we look, the simplest variable is our b. Our b is just a plain old b. So let's rearrange that to say what b is equal to. So b is equal to 3 minus 3a. That is what we are going to substitute in our upper equation where we see b. So again, write your upper equation where the b is, put a parenthesis, and then we're going to put that right there, okay? And so the 3 minus 3a goes right there. And then we just solve it. So we're going to distribute. Make sure to distribute the negative 2. So we get 3a minus 6 plus 6a equals negative 3. Combine your a's. We get 9a minus 6 equals negative 3. Add 6 to both sides. 9a equals 3. Divide by 9. A equals 3/9. Now, I like fractions. Leave them as fractions. Just reduce them. If we reduce that, we get 1/3. Now, we're not done. One thing that's nice about substitution is once we have A, we can just plug it right there, and we've already kind of made the B process even easier. So we get B is 3 minus 3 times our A value of 1/3. Well, 3 times 1/3 is 3/3, which is 1. So our answer is 2. Always put your ordered pairs in alphabetical order. So that would be 1/3, 2. So that's our solution. So that means this is a consistent independent set. So there is example 4. Let's look at example 5. For example 5, it says to use elimination. So since these are the smallest numbers and it's pretty easy to get them to match, sorry. Let's multiply this by negative 2 so that this piece right here will turn into a positive 4. So we're going to write the first equation. We didn't need to change it. The bottom equation we need to multiply by negative 2. We get negative 6x plus 4y equals negative 10. Now that we're ready, see how these are opposites. We're going to add the two equations together. We get 0 equals 0. That's a true statement. This means that these lines are overlapping or duplicates. And so because of that, the answer is all points x, y on the line, and just pick one, 6x minus 4y equals 10. And that's it. What kind of system is this? Well, this is a consistent system, but instead of being independent, it is dependent. So there's example 5. If you look at example 6, there are fractions. Since there are fractions, I don't like that. It's not super helpful. See how the common denominators of 2 and 4 are 4. So before I do this problem, I'm just going to multiply everything by 4 so that I don't have fractions to worry about. So I'm going to get 1/4 times 4 is 4/4, which reduces down to 1. And then we have plus 4y. Now, the 7/2 times 4, just do 7 times 4 is 28. 28 divided by 2 is 14. And then we have a much easier equation to deal with. So for the rest of the problem, I'm going to use the equations you see there. Now, we can either get the x's to be 2's, one a positive 2x and one a negative 2x, or we can get the y's to be 4's, and I'm going to go with that route since one of them already is a 4. I'm going to multiply this equation by 4. And so we get x plus 4y equals 14. 8x minus 4y equals 76. And then we're just going to add the two equations together. We get 9x equals 90. Divide both sides by 9. X is equal to 10. Now we're not done until we find the y value. So I'm going to plug into this top equation. 10 plus 4y equals 14. Subtract 10 from both sides. Divide by 4. Write it as an ordered pair. This is a consistent, independent. Sorry a second. Independent sort of system. So I wanted to show you one with some fractions. Because it's an equation, you get to choose. Sometimes you can start off making the equations look a little nicer before you do anything else. And our last one is a word problem, which is an example of a system. Okay, so let's read it over. It says, Margie is responsible for buying a week's supply of food and medication for the dogs and cats at a local shelter. The food and medication for each dog costs twice as much as the supplies for a cat. Okay. She needs to feed 164 cats and 24 dogs. Her budget is $4,240. How much can Margie spend on each dog for food and medication? Okay, so this is what we know. We know that the cats are 164, the dogs are 24. The total we can spend is $4,240. Now here's the line that we have to use to our benefit. It says the food and medication for each dog costs twice as much as those supplies for a cat. So we know that the cost for a dog, which we're going to call X.
Excuse this interruption, please. All Maplewood students may now be released. That's Maplewood students. You may be released at this time. Thank you.
So if X is a cost for a dog, then half of X is going to be the cost for a cat. So what do we know? Well, if we have 164 dogs and the cost for each dog is X, we would multiply those to find how much we're spending on dogs. And if we have, I switched those around. We only have 24 dogs. And their cost is X amount each. And then we have 164 cats, and their cost is a half X. And the total we're going to spend is, if I could write, is $4,240. Okay. Half of 164 is 82. Let's add those two together. Let's see what we got. We got 106x equals 4,240. If we divide both sides by 106, we get 40. It says how much can we spend on each dog for food and medication? So we would say $40. So there is just a little word problem that uses a system relating, in this case, cats and dogs. Okay, so thank you so much for watching, and you have a good day. Bye.